this video, we will be discussing how to name ionic compounds that contain metals with variant charges and hydrated ionic compounds. Previously, we have put the ionic compounds into two major categories, and the previous was discussed in a video that of metal ions containing one type of ion that has a fixed charge. In the second type, which will be the focus of this video, are naming ionic compounds containing metals that have variant charges or can form more than one type of charge. And how can you identify these ionic compounds with metals of variant charges? Well, they are mostly transition metals. So transition metals are in the mid section of the periodic table. So starting from group 3 to groups 12, in addition to lead and tin. Okay, now it's easy. You do not need memorizing. Maybe just keep in mind that lead and tin are going to be included. And let's get into the rule for naming these ionic compounds. So as we previously named ionic compounds with invariant charges, we're going to start with the name of the cation, the metal. And the new element here is we're going to add between two parentheses the charge of the metal cation in Roman numerals. And bear in mind that the charge of the metal and this portion that's in parentheses is going to be part of the name of the metal cation. And I will illustrate in the example on the next slide. And the last thing is we're going to add the nonmetal portion by adding the base name of the anion and the suffix IDE. So let's look at how we are going to name these binary ionic compounds. So in the first example right here, we have FeN. So let's start by naming iron. So it's iron. Okay, and iron, let's go back here and zoom in. We can see that iron is a transition metal and can have a 2+ and a 3+ charge. And in this case, how can I identify them? Remember, your ionic compounds are neutral. And if your nitride anion has a 3- charge, your iron has to have a 3+ charge. So it becomes iron. And then the Roman numerals come in, and look at how I attach the parentheses to the name. So it becomes iron 3, okay? And then I'm going to add the name of the nonmetal, which is nitrogen. But instead of nitrogen, we're going to convert it to nitride. So it becomes iron 3 nitride. Let's do one more example. We have here SNS. So SN here is tin, okay? And we need now to know what is the charge on tin. And if we need to know the charge on tin, we can, again, neutral compound, and if sulfide has a 2-, this has to be a 2+. So in this case, it becomes tin 2, and instead of sulfur, we will add sulfide. Okay, now I want you on the next slide to try to pause your video a little bit and try to work out these examples on your own. And while you're pausing your videos, I'm going to walk you also through how to name these ionic compounds. So for the first one right here, we have CrBr2. So Cr is chromium. Okay, and we have here, since chromium is a transition metal, and transition metals usually have variant charges, And remember, when we were using the crisscross method, right, the charge becomes the subscript of the other ion. So in this case, this must be the charge for chromium. So it becomes chromium 2 bromide. Okay, so bromine is the nonmetal, and then we'll convert this name of the anion to bromide. Now, how about Cu2O? So Cu2O, we have here copper. Okay, and in this case, remember, oxygen or oxide has a 2 minus, and here is, from the crisscross method, the charge becomes the subscript. So it becomes here. So in this case, this must be a 1 plus. So it becomes copper 1 oxide. And the last example is Hg2I2. So Hg2I2 is mercury. Okay, and remember, Hg2, 2 plus, is mercury 1 ion. So this is mercury 1, mercury 2. So let me write this down. Mercury 1 ion. Okay, mercury 2 ion is Hg2 plus. So this is mercury 2 ion. And last thing is, instead of iodine, I will add iodide. Okay, I hope this makes sense. And the last thing we're going to discuss in this video is hydrated ionic compounds. So hydrated ionic compounds, or the word hydrate means that the ionic compound contains water as part of its crystal structure. And since it becomes a part of a crystal structure, it's going to be included in the name of the ionic compound. And of course, each ionic compound has a specific number of water molecules in its structure. Now, when it comes to naming the ionic compounds containing water or hydrated ionic compounds, we're going to follow the same idea, but with a minor tweak. So the rule for naming right here is the name of ionic compound, okay, plus a prefix that indicates how many water molecules plus the word hydrate. So let's look at the examples I provided here. So in right here, we have the ionic compound, calcium. Okay, calcium has a non-variant charge, and then chloride. Okay, so calcium chloride, and then water has is present in 2 molecules, so becomes a dihydrate. So di indicates here 2. Okay, for the second example right here, I have copper 2 sulfate pentahydrate. So copper is a transition metal, has a variant charge, so copper 2. And then I will teach you later on how to name polyatomic ions, but for now, this is a sulfate anion. And then since I have 5 water molecules, it's pentahydrate.